Ladies and gentlemen, welcome to the video. Thank you very much for tuning in. And this, what you see here, is the frame of the Catalyst Machineworks WhoopMaster 4. So it's a 4-inch cinematic whoop drone quadcopter. So this frame here is meant for professionals or aspiring enthusiasts, if you will. And as you see it here, it won't fly, obviously. I'll be adding the electronics in this video. Yeah, that's what we'll do in this video. So I'll give you a tour of how to add the electronics to your WhoopMaster 4. Here we go.
You serious?
Alrighty guys, first thing I should state, disclaimer, Catalyst Machineworks did send me this drone. So the frame, as you see it here, and the electronics needed to get it in the air. So just so you know, they aren't paying me for these videos and they have no input into what I say or do in these videos. Second of all, there will be a link in the description down below to the all-in-one package, if you will. See, you can order this quadcopter in 3 ways, basically. You can order the frame kit, as you see it here, well, unassembled, but everything you see here. Second option is to get the frame kit and all the electronics for you to build the drone, as you will see me do in this video. Third option is to order everything and have Catalyst Machineworks build the quadcopter for you. So if you've never built a quadcopter or if you want to use this quadcopter in a professional environment, I'd say have Catalyst Machineworks build the quadcopter. They have excellent builders. Having said all that, we have our frame here, and the only thing I haven't added is the bottom plate. And as you see, you have full access to the inners of this frame. You won't have any problem fitting the electronics into this frame. Okay, let's get started with the motors. And that should be very simple. In most drones that is very simple. 4 screws and you're done. Maybe some tape to secure the wires. And that's it. In this quadcopter or in this frame, it's a little more, well, not complicated, but you've got that TPU print underneath, or well, basically above the motors, right? Underneath this carbon fiber motor mount, you've got that TPU print. Well, actually it's not TPU, it's a harder plastic than TPU. It's called armadillo, I think. I'm not completely sure, but again, it's somewhere in between TPU and PLA. So it's not a hard plastic, but not super squashy either. So what that means is that you will have some vibration isolation for the motors, but you will have to apply a little more force to the screws than when it were TPU. Also, the parts I'll be using, the electronics in this quadcopter I'll be using, are the same electronics that Catalyst Machineworks uses for their quadcopter kit. Or for the fully assembled one. So again, I'll be using the exact same electronics, and that means in this case motors from T-Motor, and these are the F40 Pros 2400 kV. Quite a big motor, I must say, for a 4-inch quadcopter. But as you know, the intent here is that it can carry 2 GoPros, so beefy motors it is. Now these motors come with some fastening hardware, screws, 2 types of screws or 2 lengths of screws, and some spare screws and such, and a prop knot, of course. Now what you want to go ahead and do is use the N3 obviously, by 6mm screws, no longer. Yeah, otherwise that screw might go ahead and hit the motor windings, which is the last thing you want to have happen. So again, 6mm screws, or maybe at the longest 7mm screws. Just in case your motors have a slightly other arrangement of screws. Alrighty, I've got my 4 motors in place, and the only complicating factor here is how much torque you want to use tightening down these screws. And again, this plastic is a little harder than TPU. So what you want to do is, I'll back this one out for you. You want to screw that screw down until you suddenly feel a whole lot more resistance. Trust me, you'll feel it. And then add 1/4 extra turn. There. And you will definitely sense that you've gone too far when you feel a whole lot extra resistance. So there's at first resistance of the TPU print, right? Then you do a quarter turn. After that, beyond that, you'll feel a whole lot more resistance. If you feel that much resistance, you know that you've gone too far. Right, okay, so also you could opt to use some Loctite on these screws. Blue Loctite, not red Loctite, blue Loctite. Definitely a good option. Now the last thing about adding the motors is, well, tape. I mentioned tape, taping the wires to the arms. Not really needed. As you can tell, these arms are short. The distance from the motor to the 4-in-1 ESC is short. So you don't need to support the wires with tape. Definitely not needed. Maybe I will, not really needed. Okay, the next step will be adding the battery strap. Yeah, it might be a little strange to add a battery strap now, and I usually don't, but it'll be hard to get to well, the slots for the battery strap after you've added the 4-in-1 ESC. So run your battery strap, at least the center one. You will probably add a second strap to the rear over here, but you don't need to run that one down right now. Again, if you want to install that strap after you've added the 4-in-1 ESC, you will struggle. That gets us to installing the 4-in-1 ESC, which I've already test fitted, as you can tell. It's still loosely in place. So what I've done is I've run 4 bolts into the frame. These are M3 bolts, and I'm not completely sure, these are about 18 millimeters in length. And I've secured those in place with self-locking nuts. Now the frame actually comes with plastic nylon bolts, which will also work. I prefer metal ones, so I've used metal ones. Yeah, so and the 4-in-1 ESC itself will slot onto those, as you can see here. I have pre-prepared the 4-in-1 ESC. I've soldered up the motor tabs on the 4-in-1 ESC, the 12 motor connection tabs, as you can hopefully see. Nice and shiny, which is what you want. And I've soldered up the capacitor to the rear over here. Now, point of note, this is not a how to solder, how-to. See, if you can't solder yet, this might not be the first project to take on. I'd say that if you can't solder well enough yet, get Catalyst Machineworks to install the quadcopter for you. You've paid a lot of money for this quadcopter, you want it to be well and good, right? So again, but if you are proficient in soldering, again, pre-tin all the solder pads for the motor wires and then solder up that capacitor. Handy to do that out of the frame. And the next things, is soldering up the motor wires, right? Yeah, motor wires, and you'll need to snip those off to length and make sure they won't interfere with, for instance, over here the slot for the XT60. Right, run them in a curve to those pads, and over here on the right side of the frame, yeah, the right side for us now, will be the spots for the FPV antenna, right? So make sure that motor wires don't interfere with those spots either. Other than that, pretty straightforward. Snap off the wires to length and solder them up to the motor tabs. And that then looks like this. The ESC will sit a little bit lower, like so. But yeah, we'll screw things down, obviously, after we've added the flight controller. And again, this is not a how to solder video, but all your solder blobs should look nice and shiny. And yeah, mechanically sound, obviously. So the next thing we'll do is add power leads. So those will run from over here, where your capacitor sits, to the XT60, which I've screwed in place already, as you can see. So that's held in place by 2 M2 bolts running from the top. Nice and simple. So we'll be running power leads from over here to over here. And I must add, by the way, that these Aken 4-in-1 ESCs look very, very nice. But you probably already knew that Catalyst Machineworks uses nice electronics for their builds. Okay, I'll be adding the power leads, and that look like so. And that is what this will look like. Well, actually, you could opt to use longer wires and route them like so, extra slack in them. And I personally like to have these power leads as short as humanly possible. I don't want them to flop around, potentially getting caught in the propellers even. The horror. Yeah. So yeah, I shorten those down well and good. But again, you could route them like so in an arch, have them be a little longer, no biggie at all. Okay, and you can also see that I've attached this wire loom that'll run to the flight controller. Now if you get this Aken set, so the ESC and their flight controllers, you will see that you'll have like 3 or 4 of these wire looms in different lengths. And the one I have here is a little longer than needed really, but and also I'm not completely sure what flight controller Catalyst Machineworks will include in this set. This is an Aken F722 version 1.1, which is fine, it'll work, and it hooks right up to that ESC over here. But it is also possible that they ship the set with this ESC, which is a version 3, a slightly newer one. Functionally, no real difference. However, this one has over here a DJI plug. So that'll make installing your Vista a whole lot easier. There's less soldering, right? And the pads on these small flight controllers are small, so it'll save you a lot of fine soldering. You will still have to solder up your receiver. Well, actually, if you use a DJI remote controller, you won't have to do that either. But I will. I'll be using a crossfire receiver in this build. So same thing, that wire will hook up to this flight controller as well. And again, maybe Catalyst Machineworks will let you pick the flight controller of your choosing. Functionally, again, there's no real difference other than less soldering. And you'll quickly be able to see which version you got. The difference is obvious, right? Yeah. Okay, so in the rest of this video I'll be using the version 3. And again, no real difference other than soldering. Also, as you can tell, I've got the flight controller turned. The arrow pointing to the front of the quadcopter is pointing that away. And that is because I've turned this flight controller 90 degrees. And why? Well, this way my USB connector will be facing rearwards, giving me easier access to that USB port. Now the set will probably come with an extension cable for your USB, so it ultimately doesn't really matter. And otherwise you could simply take out 2 of these posts and then be able to reach your USB port. Also, you won't have to reach that USB port all that often, but as I will be tuning the quadcopter, probably I want access, easy access to that USB port, so I'll be rotating the flight controller 90 degrees. And I've taken a couple more steps in my build here. As you can tell, I've loosely installed the Vista, and I will be mounting my Vista in front of the flight stack, as you see it here. Now, Catalyst Machineworks also offers the option of mounting your Vista underneath the stack, basically mounted in the bottom plate of the quadcopter. And you'll be using this 3D print to house the Vista in, basically. So that's definitely an option, and that option is a lot easier actually because I've used that plug. You will probably see that, well, you'll be installing the bottom plate, having less access to your electronics, and then have to fiddle around with the cables to the Vista. That connector will make life a lot easier, in that sense. But I will be installing my Vista at the front, as you see it here. I've not screwed it down, as you can tell, because I need access to that USB port to, well, activate it and possibly update the firmware on my Vista. Other than that, I could screw it down. One more thing, ordinarily, you see this wire loom running to the Vista, right? Ordinarily I wouldn't use all these strands, because two of these strands are for control, for S-bus control, and those would only be used if you were to use a DJI remote controller, which I don't even have actually. But I wanted to show you this because this is better, especially in a production environment. For instance, what if your crossfire transmitter failed, right? Or that crossfire signal interferes with other things on set. Well, now having these S-bus wires running from the Vista to my flight controller, I have the option to simply go into Betaflight, say, well, I want to use this remote controller, and then switch to that DJI remote controller. So again, in a production environment, you'd want to have that DJI controller as a fallback, in my humble opinion, of course. But yeah, that way you'd have fallback for two scenarios: your crossfire not working for some reason, or crossfire not being welcome on set. Right, okay, so that's again why I've used all these wires. I won't set it up in Betaflight. I think it's UART 1. Yeah, I've checked. This is UART 1. So again, if I had to switch to this control option in the field, I'd simply have to switch to UART 1 for my control, in Betaflight to UART stop or port step, and I'd be good to go basically. Right, however, I will be installing Crossfire, and that'll require obviously a separate receiver, which I will install over here on these pads over here. And conveniently there's a UART over here and 5 volts, and it'll be UART number 2. So there's an R2 and a T2 over here. I'll show you a diagram of my flight controller, and yeah, convenient. So, and 5 volts and ground. So let me see, yeah, the DJI Vista set will be using UART 3 for telemetry, which is needed for your OSD, right? So that's incorporated in this plug over here. Yeah, and that's it. So let me show you what that looks like, having the Crossfire receiver installed. And there you see the Crossfire receiver installed. Now you are looking at the top basically of the drone, right? It's a bit counterintuitive. It'll flip on over. So basically this line over here will be the bottom of our drone, and I'll be mounting my Crossfire receiver to that bottom plate. So it'll be over here like so. Right, and yeah, I'll stick it down. Maybe I'll actually use some Velcro, I'm not completely sure. I like my quadcopters to be serviceable, right? So you might want to have to take off the bottom plate from time to time, but well. Okay, so, one thing I should definitely mention, now that you've got your Vista installed, never power up your quadcopter without the FPV antenna, this thing. Yeah, and in case it wasn't obvious, I've used a pigtail, an SMA pigtail from the Vista over here to that FPV antenna mount over here. And then I can simply screw on my FPV antenna when the quadcopter is ready. Otherwise it would be in the way right now, right? Also for the Crossfire antenna, that'll live here, and the quadcopter comes, or the frame comes with this mount, or maybe that's optional. But if you order the kit, so the frame with all the electronics and such, you will get it with the frame. So you, again, my Crossfire antenna will live over here in that mount. So that should work out brilliantly. Yeah, also I have now screwed down the Vista over here. I must say it's very convenient. Yeah, it is less convenient to get to the USB port over here. So you'll probably want to use a USB-C cable with a right angle adapter, right? Or a cable with a 90-degree connector, which I have, so it won't be a biggie. But yeah, this will definitely be more convenient in your build than having the Vista up here underneath your flight controller. It will, however, require you to use a pigtail such as I have over here. Otherwise, the ordinary FPV antenna that comes with the Vista wouldn't be long enough to reach all this way. This way you can use a longer antenna as well, which is preferable for a quadcopter like this. So yeah, that is basically that's the entire installation of all electronics in this quadcopter. Now I won't show you my Betaflight setup, as I haven't tested this quadcopter yet. Right, I haven't flown it yet, and I don't want to misinform you. Maybe I'll do a separate video on the Betaflight setup, even though it's pretty simple. It's an ordinary Betaflight setup. The most difficult part really is that the flight controller will be upside down. Yeah, so flip it 180 degrees in a roll axis in the Betaflight, and that's it. Otherwise it's a completely normal Vista and Crossfire setup, and there are heaps of videos about that already, so I won't waste your time with another video on how to set up a Vista or Crossfire. And yeah, so Crossfire is obviously a TX to RX, RX to TX, and that's it. So I will be doing a review, a roundup of this project, a review of the quadcopter itself, how useful it is as a video platform, and in that video I'll show you my Betaflight setup, maybe the tuning, that should be interesting. And for now, if you are left with questions, don't hesitate to ask me them down below in the comment section, might help other viewers as well. And I want to thank you for watching. Catch you on the next video, bye bye.